Hi, my name is Roxanne St. John, and today we're going to be talking about my presentation of the Cosmic Webb, also probably better known as the cosmos as we know them through our very fancy, very new James Webb Telescope. So if you're not familiar, the James Webb Telescope has showed us a lot. So I want to focus in on the cosmological principle that we discussed at the very beginning of this class and how that is kind of being changed here through what we're seeing with images from the James Webb Telescope. So throughout this presentation, we're going to be talking about what the cosmological principle is, what we've seen, what we know or thought we knew, and then we're going to have a cute little crisis time. So the cosmological principle is something that anyone who's taken this class should be relatively familiar with, but it was like the first thing we talked about. And it's just the concept or the idea that on huge scales, like metaparsec level scales, the universe is both homogeneous and isotropic. So this is the underpinning of our understanding of cosmology. The universe is pretty much same as long as you zoom out really far. And we can develop models, and we have developed models and observations to constrain those models, provided that they're over a sufficiently large volume to apply. That being said, we have not measured how homogeneous the universe is on smaller scales directly. We've only kind of taken these large images and tried to put them together. So this is the cornerstone of really how we feel or what we think the universe looks like at large. So here's where we get into the article that just talks about the James Webb and what's it shown us and kind of goes over different exploratory things that we've seen through it. And it's worth noting that the James Webb is the most powerful telescope ever. So we've seen deeper into space, or farther away rather, with the James Webb than ever before. And with that, it's useful to keep in mind that when we look across the universe with a telescope, that we're viewing things that are light years away. So, because we are looking at things that are so far away and light has not reached them to us yet, by the time we see them, we are actually looking at them however many millions or billions of years ago they existed at that point, because the light for how they are presently has not reached us yet. Almost like a little visual time machine. And that's important to keep in mind, especially when we start to look at the pictures that we have gotten now that we're sticking our nose a little farther out than we were able to before. Here's one image that comes from the Webb Space Telescope directly, and it shows different wavelengths of light for different galaxies in the very early universe. And something that's interesting to note here is there's still about twice as many massive galaxies in this early universe data than we thought there was going to be. So it's possible that the galaxy was actually way better at making stars in the beginning than we thought that it was. So here's what we know. Here's the life stages of a galaxy, right? They have to go through certain things. So we start with very light metals or gases, hydrogen, helium, things of that nature. And they have to take time and they have to compound in order to fuse and make those heavier, older, or make those heavier metals that only older galaxies are capable of doing, right? Galaxies, first of all, we're seeing that are very far away shouldn't exist at all. So because they're so far, that means they're extremely young when we're looking at them in relation to the Big Bang Theory. And they shouldn't be at the stage that they're at already. And in addition, these galaxies that formed much sooner after the Big Bang than we thought was possible have metals that are way heavier than would be possible of galaxies of that age in the first place. So, what is going on? Is the cosmological principle still tied to this? I would argue yes. So, we're looking at these things very far away and we're seeing, hey, what we've built our structure on, how we think the universe works, isn't necessarily correct. And as we're looking at these galaxies that are way older and way heavier than we thought was possible, we're also looking at much a wider swath of the universe, and we're finding that the homogeneous and isotropic properties are not holding. There's huge gaps, and then there's huge densities, and we're actually looking at our area of the universe being a little light when it comes to those densities, and we're not quite sure why that is. So, now is the time for crisis, also known as the timing of this is impeccable. And the reason I say that is because although this is super exciting, this is kind of a crazy time to see that the James Webb is showing us things that would create huge paradigm shifts. A paradigm shift being where there's one explanation for something that's very widely accepted, and then that's its own paradigm. Someone discovers something new that challenges that paradigm, and people start testing differently or noticing different things or drawing connections that they didn't beforehand, and that narrative of what the right answer looks like starts to shift, and that's what is referred to as a paradigm shift. So we go through this huge paradigm shift of, oh, we didn't know what we thought we knew. And this huge paradigm shift occurs, and then we'll land at whatever the new paradigm is, which is the new place where we get settled. And historically, these don't happen insanely often when you compare them to the span of, let's say, how long it takes to get a degree in something. And so I think it's really fascinating to go through this course, and this being the last course before my capstones, and talking about the cosmological principle and going through all of this math and going through the entirety of this, and then at the end of this course, seeing that there's writing on the wall that everything we just learned might get thrown out the window. And there's obviously underlying math and physics there that are probably going to hold true. But the idea that we're in a place, we have a degree, or what we're studying right now is just so up in the air, and we don't have those right answers, that to line up graduating in 3 months with also maybe the cornerstone, the cosmological principle, the absolute foundation of how we thought the universe was built and what it looked like, might just be completely wrong. And it's because we built a great big telescope that just took really cute pictures and now destroyed the entirety of what we know to be true. So anyway, here's why we're excited. All of the images that were used here all came from it. All came from these sources. Is astronomy is in crisis, and it's incredibly exciting that Kyrgyz Sak's YouTube video is a 12-minute version that goes a lot more in depth than this and is very good. And it talks about not just the cosmological principle, but everything that we've gotten from the James Webb that is showing that we don't know what we're talking about. And so highly recommend that, but wanted to keep it just to the cosmological principle here today because I thought that it was just so interesting that something brand new that we came out with could touch and correlate so strongly with literally the foundation of not only our understanding of science, but of this course. This is literally the first thing we learned about in this class, and it might be completely upended by the next semester. I thought that was really neat. So anyway, thank you so much. Enjoy and keep looking up.